Okay, we have continuously heard about the second moment of inertia. What is the second moment of inertia? It's actually the resistance to rotation according to the axis. Okay, so second moment of inertia resist rotation according to its axis. Let's say we have a normal axis here, x, y, and z. So the ix, the initial x, represent the resistance according to the x axis. So y axis is called iy, and z axis is called the iz. Okay, so the formula says that the ix equivalent to the y dA, whereas for iy the x square dA. Okay, for example, we have one beam with its centroid at the center of function. So the width is b over 2, total to b, and the height is equal to h for its total height, comprising of h over 2 and another h over 2. Okay, so let's say there is one element here, element dA, call it element dA, that need to be rotated through the axis. So we can say that the ix is equivalent to the integration of y square dA. So what is dA? dA is equivalent to the dy times b. Okay, this is the dy. Okay, in terms of y direction and also the whole b. So it becomes the integration of y dy b. b y dy. So the integration of y square, you have the y 3 over 3 for the hn2 minus hn2. So finally we have the ix equal to b h3 over 12. Okay, similarly if you have one element here, okay, vertical to x-axis, rotated through the y-axis. Okay, so we have the iy. This is the ix and it is the iy. So what happened to the iy is equivalent to the integration of x squared dA. Okay, so similarly, what is dA? It represents the dx times h. So we have the integration of x squared dx h equivalent to h x squared dx. So you have the h x3 over 3 for the next b and negative b over 2. So finally you have the iy equivalent to hb cubic over 12. Okay, so please take very serious attention to the h over 3 and also b over 3, whereby the geometry b and h is related to the axis where it is rotated. So in other words, the geometry b and h depends on the rotated axis. Okay, for the fixed geometry, it stays, whereas for the vertical, it will gain the cubic function. So let's say for this one, for the x, so the b is fixed, but the h is varies, and then the h will has the cubic function. Whereas for the iy, when it rotated to the y-axis, the parallel y or the parallel h is fixed, whereas d varies in b, resulted in the b cubic function. So this is the what you call it as the second moment of area. Thank you.